Pre-calculus, second part of 5.1 homework.
Number 31, you are going to subtract these radicals. They're both the same index of 2, so you're going to simplify. This is 2 times 2 is 4 times 5 is 20. So you pull the 2 out. So you have 4 root 5 minus 2 root 5. 4 minus, since the indexes and the radicands are the same, the answer would be 2 root 5. Number 33, you are going to FOIL. And because it's the difference of two perfect squares, all you have to do is multiply the first two. 3 times 3 is 9. And root 2 times root 2 is minus 2. So 7 is your answer. Number 35, 2 root 5 times 3 root 5 is 2 times 3 is 6 times 5 is 30. And then times 2 root 5 times 2 is 4 root 5 minus 12 root 5 and then minus 8. These two add up to be negative 8 root 5, and 30 minus 8 is 22. 37, you're going to simplify. 20 is 2 times 2 times 5, so this would be 2 times 5 is 10 root 5. Then minus, this is going to be 3 times 3 times 5, so minus 3 root 5. Because you have a 9 times 5, you take out the 3. And this is going to be 8. 8 times 10. So that would be 2 2's, which is 4. 4 times 2 is 8. So it would be 8 root 5. So you took these two 2's out. 2 times 2 is 4 times 2 is 8. 8 root 5. There's a 5 left over. So 10 minus 3 is 7. 7 and 8 is 15. 15 root 5. Okay, next one. This is saying 2 to the 11 halves, and 11 halves is 5.5. Okay, that's 11 halves. Times 2 to the negative 7 times 2 to the negative 5. What you're going to have to do is you're going to have to add these exponents. And we have 2 to the, I believe that's a 3, times 2 to the 0.5 times 2 to the negative 10. So we're going to add those exponents. Now there's other ways you could do this. You could flip-flop these and cancel. Bring the 2 to the 10th on top and 2 to the negative 5th on the bottom, and you can cancel, and you have 2 to the... So you could simplify this problem if you want. There's several ways to do it. What we're going to do is, since we're multiplying on top, we're going to keep the base the same. And let's add up what is, these two add up to be negative 12. What's 5.5 minus 12? So you have 12 minus 5.5. So this would be 11. So this would be 5. And so you have 6.5. So on top you have 6.5 over, and in the bottom you have 8 and then negative 2. So what you're going to do now is bring these two add up to be 8. I'm sorry, that's 0.5. My bad. So 3 plus 0.5 is 3.5. Negative 10, and we have 3.5. So this is going to be negative 6.5. So let me check this again. This is 3.5. And minus 10, this is going to be negative 6.5. Now this goes up here. So you have 2 and 6.5, you're gonna have a positive 6, another 6.5. 6 and 6 is 12, and 1 is 13, so this is 12 to the 13th power. 2 to the 13th power. Number 41, you're looking for square root. This is gonna be 16, and 4 times 4 is 16, so the 4 comes out. And you've got 8, a to the 8th power. So a, if you look at this as 8 over 2, 8 over 2 is 4, so it's a to the 4th. And this is gonna be b to the negative 2 power. So you have negative 2 over 2, which is negative 1. And so it's gonna be b on the bottom. This is equal to negative 1, and that would just bring that on the bottom. Next one. Since these are, and I'm going to rewrite this because it's very difficult to read. Since both of these indexes are the same, you've got c squared d to the 6th over 4c cubed d to the negative 4th.
Calculator tomorrow.
A graphing calculator?
Yeah.
When are you bringing it back?
Oh, probably by the beginning of next hour.
Okay. So you can cancel these C's out. 2 C's with 1 C here. So you have a C in the bottom. And then these 4 D's, which are negative, will come up on top. You have D to the 10th on top. And then you have a 4 still down here. Now, we're taking the square root, so you've got 10. If you rewrite this numerator, you've got the square root of D. You've got 10 of them. So this can be written as D to the 10 halves, which is 5. And on the bottom, you've got the square root of 4. So what you have here is D to the 5th over 2, and then you have the square root of C. Now, you're not going to want to leave a square root on the bottom, so you're going to multiply by square root of C. So your final answer would be D to the 5th square root of C over 2C. That's your final answer. Number 47, I would rewrite this as 7x to the 7 halves power. Square root of 7 is 7 halves. And you've got 5 halves here. And you know you can add these. You get 12 halves. And then you have x to the negative 3 halves. So x to the 12, this is 12 halves, which is 6. And then you've got, you're going to subtract 6 over 2. I'm sorry, 3 over 2. And 3 over 2 is 1.5. So 6 minus 1.5 is really 4.5. So this is really 6 to the, x, not 6. Now you've got x to the 4th power. This is your whole number, so you're going to have x to the 4th power, and that's a half, so you're going to have the square root of x left. That 0.5 means that's what you have left. Now you could leave your answer like that, because half of your answer is written with rational exponents. So technically, if this is mixed, it wouldn't matter which way you wrote your answer. I think this would probably be my choice. Next one. This one you've got, first you're going to want to distribute this 6 times 4 thirds. So 6 times 4 thirds, you've got 6 times 4 thirds. 3 goes into 6 2 times, so you've got C, this is going to be C to the 8th power. And then you've got this 3, these 3's cancel, so you've got D to the 4th power. So this is this right here. Now we're just going to bring down 2/3 and d to the negative 2/3. So now what we have to do is add these exponents. 2/3 plus 8. So what is 2/3 plus, you're gonna make this 24/3 to get a common denominator. So this is gonna be 26/3. So you have c to the 26/3 and then add these two up. So you have 2/3. You have negative 2/3 plus 12/3, because that's another name for 4. And this is gonna give you 10/3. So d to the 10/3. So that would be that answer. '51. You have 7, you have to square both of these. So you have 7 squared and a squared. Then you've got 5 to the 3/2 power, or you could write 1.5, and b to the 1.5 power, over, you've got 5 to the 1.5 power. You're distributing this power, a to the 3.5 power. And then you've got 7 to the 4th and b to the 4th. Okay, so now we need to start canceling. Right away, I see this. These are a match, they're gone. Now, as far as the numbers go, we have 2 7s here and we have 4 7s here. So let's cross them out, let's make a fraction, and we have 7 squared, which is 49. So those are gone. As far as the a's go, we have 2 a's on top and 3.5. If we were to subtract them, if you did 2 minus 3.5, you have negative 1.5, so you have 1.5 below. In the bottom, you have 1.5, and if you subtracted, you have 2.5. That would give you 4. 1.5 minus 4 is 2.5. And what's on top is a 1. Now, if you wanted, you could rewrite this in several different ways. You could write this as 1 over 49, and then you could write this as, if you wanted to write it as AB, and then you could write the square root of AB, because you had a half here, and actually this would be B squared, because you have 2 of them, and then half of B, which is a square root. So that would be another form of the answer. These next 3 apply power to power rule. If you look inside here, this is a to the 3/4 power. So the 4th root of a cubed is a to the 3/4. And then you're going to raise this to the 1/4 power. So you have outside here a 1/4. So this is a power to power, so this is going to be a to the 3/16. You have to multiply these two. Next one, this is going to be t to the 1/5 power, be 1 to the 5th, times, then we have 16 to the 1/2 power, which is 4, and then we have t to the 5/2 power. So 16 to the 1/2 power, that's just a 4. Square root of 16 is 4. And now these two, we have to add these 2 exponents. So what is off to the side, what's 1/5 plus 5/2? Our common denominator would be a 10. So 2/10 times, multiply this by 5, 25 tenths is 27/10. So, now let's erase this for some room. Now I'm going to convert this answer. 10 goes into 27 how many times? It goes in 2 and 7/10. So if I wanted to convert this back to with a radical, it would be 4t squared, and then it would be the 10th root of t to the 7th power. So we have 7 left over, the index is 10, we had 2 that came out, and we had a 4. That would be the best answer. 63. I'm going to first convert this right here. This is going to be x to the 1/3 power. It's going to be x to the 1/3 and y to the 2/3 power. That's what this circle, that's what you have here. And all of this is going to be to the negative 3/5 power. So now we have a power to a power rule. We have to multiply these two together, 1/3 times negative 3, the 3's cancel, so you have x to the negative 1/5, and then you have y, and then these 3's cancel, you have negative 2/5. So what this means, the negative exponents means we bring them in the denominator. Now what these mean, this 5th index means in the denominator, we have the 5th root, and then we have 1x, and we have 2 y's. And on top we have a 1. Now the next step would be to rationalize the denominator. And what you would need to do is multiply the top and the bottom. If you were to rationalize this, you would need, you're in need of x to the 4th, because you need to make 5 of these, and you're needing 3 y's. So you would multiply the top by the same thing, x to the 4th y cubed. So on top you would have the 5th root of x to the 4th y cubed over 1x, because now you have 5 x's and 5 y's. That would be rationalized. For 67, you are multiplying x to the 1/2 times x to the 2/3 minus x to the 1/2 times x to the 4/3. You've got to get a common denominator, which would be in the 6's. So multiply this by 3, so 3 6 plus 4, so 7 6 minus, and then this one multiply by 3, multiply this by 3, so 3 6, multiply by 2, multiply by 2, and then 8, so we have plus 8 6, so you have x to the 11 6. So let me double check, multiply this by 3, 3, 2, 2, 8, and 3 is 11, there's your answer. Now this one you're going to FOIL, but because it's the difference of 2 perfect squares, you only have to multiply these two and these two, because the middle 2 will cancel. So what would x to the 1/2 power times x to the 1/2 power be? Well, if bases are the same, you're going to add these and you just get an x. Same with these two, y to the 1/2 times, it's going to be a minus, by the way. Y to the 1/2 times y to the 1/2 is going to be, bases are the same, so you leave the base the same and you add the exponent. .73. You're going to rationalize the denominator. This problem is really 3 over 2 root 2, because 8 is 2 root 2, so you're going to multiply top and the bottom by square root of 2 of square root of 2, so it's 3 root 2 over 4. Number 74, multiply by root 6, so it's 2 root 6 over 6, and these two, the 2's can cancel, so you have root 6 over 3. For 75, you have, you're going to want to, you could simplify this if you wanted to. You don't have to. You could do that at the end if you wanted to. The conjugate would be root 2 minus root 12. You can do your simplifying at the end. So 3 times 2 is 6 minus 3 root 12 over 2 times 2 is 4. And then the next 2 will cancel out, and root 12 times root 12 is going to be minus 12. Now, 6 minus 3, you're going to have a 2 in here, because 12 is 2 times 3, you have a 2 here. So this is going to be 6 minus 2 times 3 is 6 minus 6 root 3, and this is going to be negative 8. Now, I would reduce these all by 2's, so you have a 3 here, a 3 here, and a 4 here. So it's 3 minus 3 root 3 over negative 4. In 77, you're going to multiply by the conjugate, which is root x minus 2. Root x minus 2. So you have 2 root x minus 4 over root x times root x is x. Root x times, these next 2 will cancel, and then you have minus 4. Now, we don't have any more radical in the denominator, which is fine. These last 3, you are going to factor. It says factor the given expression, for example. Let me give you an example there. What you're going to do is think about factoring. How would you split up 2/3? Well, you got to think of 1/3 plus 1/3 is 2/3. Then right here, what 2 numbers multiply to give you negative 6 but add to be 1? So this is going to be a 3 and this is going to be a negative 2. This one, you're going to break up, this is actually one whole right here. So you're going to make this 1/2 and 1/2. And what times what is 3 but adds to be 4? You got a 3 and a 1 here. So if you were to FOIL this out, x to the 1/2 times x to the 1/2 is x. And then x to the 1/2 times 1, and 3 times x to the 1/2 is 4x to the 1/2, and 3 times 1 is 3. And the last one, this looks like the difference of 2 perfect squares. So you're going to have, obviously, a 9 and a negative 9. And how would you split this up? This is going to be x to the 2/5 and x to the 2/5. Because 2/5 times 2/5 is, you're going to add these exponents and you get 4/5. And we are done.